Hello and thank you for watching. My name is John and you are watching the Crash Course to Maya series nCloth, Section 3 nCloth Basics. In this video I'm going to talk about the location of the nCloth, the difference between local space or world space, and creating a basic simulation which is a tablecloth. So let's get to it then. First thing is I want to show you where the nCloth is located. If you go to the drop down menu you'll see there's Dynamics and End Dynamics. You want to go to End Dynamics, and your menu bar is going to change. nCloth is going to be located in End Mesh, right here. The difference between a collider and nCloth is a collider is anything nCloth is going to collide to, like skin, table, or anything of the sort. So let's get to it. Let's go to the Create nCloth option box, and it's going to pop up this window. It's going to be a very basic window with two radio buttons and a drop-down menu. Local space output and world space output, which I'll explain here shortly. So the difference between local space and world space is pretty crucial. Local space is when you create nCloth and it creates the output mesh. When you move the output mesh, the input mesh and the output mesh move the same. Whether it be translated, rotated, or scale, it's going to go with it. World space is when you move the output mesh right here. Only the output mesh is going to move and the input mesh is going to stay, like I'll show here really shortly. So when I play this simulation, you'll notice that it drops and it starts wrapping around the cube. As I start moving down, you'll notice it looks pretty much identical. So let me demonstrate the difference between local and world. So let me just select both of these and move these away. Make sure they are away from the cube. Now I want to play the simulation. You'll notice a big difference right here. As you can see, the world space is wrapping around as if it was still on the cube, yet the local space is just going straight down. And demonstrate there's no cube underneath the world space as is. Doesn't matter what you do, you can rotate, scale, whatever you're going to do, it's going to fall just as if it was still above that cube, scaled up. Now that we know the difference between local space and world space, we're going to do an example. This is the desired outcome. As you can see, it's just a cloth on a table using the grid as a ground plane. So let's get started. In this scene file, all I have is the table and the cloth. So what you do is you select the cloth you want to make an nCloth, end mesh, create nCloth. What's going to happen is going to convert this into an output mesh, and you're going to get an object nCloth 1. And when you push play on the simulation, this is going to go straight through the table, and as you can see shortly, straight through the grid. So next would be to actually make the table a table. Just select the object you want to collide, and mesh, create passive collider. It's going to create an end rigid node, as you can see in the outliner, and when I push play, you'll see the tablecloth start to fall and start to wrap around the table. A couple of things to note. One, it is not going, it's not using the grid as a ground plane. And two, once we go above, you can see it's kind of stiff. This is where some of the attributes come in handy. So we're going to start modifying the cloth itself. In order to do that, you select the cloth, go to the attribute editor, and you'll see nCloth shape. In the nCloth shape, you're going to see collisions, dynamic properties, force field generation, wind field generation, pressure, and a few others. Collisions work with the nCloth object and what it collides on, such as the end rigid one. Dynamic properties actually works with the cloth itself, whether it be how thick it is, how much it rubs against stuff, etc., etc. Force field generation is what it works with the fields generated, such as air, gravity, etc., etc. Wind field generation is how much it works with the wind, with the nCloth. Pressure, I'll explain later. Quality settings, if you have cloth kind of going inside itself and not fixing itself, this is where it's going to be coming into play. pushing out, iterations, and all that stuff. I'll talk a little bit about that later. So I want to rewind this a little quick. So let's go select the object, nCloth shape. We're going to mess with the dynamic properties. You'll notice stretch resistance, compression resistance, bend resistance, rigidity. I'll talk a little bit about mass and input mesh attract. The input mesh attract I'll talk a little bit about later, but those are really the ones I'll be talking about at this current point in time. Stretch resistance is how resistant it is to stretch on itself, as you saw in the triangle example. Compression resistance is how much resistance it has to compress on itself. Bend resistance is basically how resistant it is to being bent. I can actually do an example here because this has some bend. You can notice it's bending there, but if I up it to 10, continue the everything, it's going to flex out, as you can see. I'll go to the side view so you can see a little bit easier. And I'm going to put the bend resistance to 0.1, which was the original default. Push play, it flattens out here, and it starts to bend around the table. Now I want to go back to the beginning. I want to go to rigidness. This is a very touchy attribute. I'll even have it bend like that, and I'm just going to turn it to 0.1. I want to zoom out so you can see how intense 0.1 will be. You see it's shot straight up. The reason being is, restart the simulation. Rigidness is how much it's going to keep its original shape. It's going to be very stiff, like a board. And if I zoom in, you'll see a very slight indentation right there. I don't know if you can see it because it's just very slight, but that's how powerful it is. So I want to keep that at 0 for tablecloth. Now mass works with gravity and other major dynamics. So it's currently at 1, so let's put it to 10, and you'll notice that it'll drop faster onto the table. In addition, it's going to carry more velocity on the tablecloth itself, and it's going to sway underneath the tablecloth a lot more, as you can see. And if I keep running the simulation, it's going to start rocking back and forth because it's very heavy. It has a lot of momentum. So I'm going to stop that, rewind it, and put the mass back into 1. So with our original, with our default settings, what we need to change isn't the stretch resistance, not compression, but the bend resistance. So I'm just going to drop this to 0.01. And it kind of flattens out, becomes a little bit more like cloth. If I start going up on the top view, you can see it's more like cloth. So this is a start. I'm going to rewind it back to the beginning. We're just going to stick with that for now. Next thing we need to do is we need to have the ground plane as the ground. Sure, I can just make a plane, go to nMesh, and go create passive collider, but you already know how to do that because of the table example. So we're just going to actually have the ground plane do it. In this case, this is a worldly object, so you need to go to the nucleus itself. So go to the nucleus, and you'll see wind and gravity, ground plane. This is what you're looking for. And if you push use the plane, it'll make this, the ground itself, into a collidative object. So when you push play, the tablecloth's going to fall like usual, but as soon as it hits the plane, it's going to actually hit it. Now there are a few things to note. One, the ground, since it's really smooth, doesn't really give a good fold on the bottom. In addition, it kind of slides a little bit on the table as it's starting to go down. So we need to fix the friction on that. Since the ground plane is a worldly object, you need to go back to the nucleus and plane friction. I'm just going to turn that to 1. So when the cloth hits the ground, it kind of resists a little bit, gives a little bit better of a deformation. In addition, the table is too smooth. It's almost as if it slides too easily. So we need to go to the table, select that, go to the end rigid shape, and friction. We'll turn that to 1 as well. So now, when I push play, The table's gonna be a little bit more friction, has a little bit more friction, and the ground has more friction. And you'll see the tablecloth when it hits the ground have resistance to going underneath, as you can see. And that is just about how the sample looked. So that's it for section 3. Next is going to be section 4, transforms. Transforms basically work with the cloth sections, so you can actually work with it to either hold it or give it some sort of effect that you want. I'll be talking about making 2-point or hanging cloth in 2 points. Trampoline, we'll be talking about like a cape on the back, and more. Thank you very much for watching. Please feel free to leave a comment or message me if you have any suggestions. Have fun.